Again, my name is Jason Haworth. I'm the Chief Product Officer at Apica. With me is Daniel Bengtsson, our Director of Customer Success. So commonly deployed monitoring solutions in the wild today. If you look at kind of the monitoring tool chain, you've got things like application performance monitoring, synthetic monitoring, real user monitoring, load testing, network monitoring, and log analysis. These are typically found in most people's environments somewhere to some degree at some level. And all of them are really good at providing context within their realm and area of specificity. What they're not great at is kind of tying the whole picture together so that you can understand what your end users are actually experiencing. And that's what we focus on. So your typical APM, STM, and REM tools were all built with this idea that we're going to test web application endpoints, and they've got very limited support for non-HTTP applications, and most of them don't have great support for MFA. They'll support some kind of key logic. They might be able to go through and scrape something from Okta, or potentially pull something in from an SMS token. But getting past that with things like physical card transactions, they just can't do. Load testing platforms tend to focus on single object calls and not the full user journey testing. So we do tend to create these full user journeys. So that last demo that we talked about, where we go through and we create these different scenarios and these deployment kits, that's when we start being able to do these full user journey tests. And it's a stack of different scripts and different variable calls to make sure that we're testing all those pieces end to end. And most of these systems are passive data collectors, and they don't really generate traffic. Generating traffic, we create these consistent time series data sets of traffic moving in a certain period of time, lets you go through and understand these things over a protracted period of time. And when the peaks and valleys tend to fail, that's when you know you need to look and focus on something of value. And they have limited real-time view of the actual end-to-end application uptime. They're showing you spot components. And spot component testing is people that do this today in those real-world environments. They do that really well. We're not trying to emulate that. We're not trying to replicate that. We're trying to bring you the visibility from the people that actually use your application, the people that are going to call, the people that are going to disrupt your IT teams, the people that are going to mess with your DevOps and SysOps folks while they're trying to track down these problems. We're trying to head as much of that off at the pass as possible. So we look from the outside in, and we covered this a bit in the last conversation, but really what we're able to do is we can go through and make sure that your app's dependencies, the transit path, the DNS, distributed stack environments, all those pieces can get monitored as a broader aspect of what your application's actually doing, while continuing to do all those synthetic transactions and capturing those full user journeys. And that lets us do things like critical performance issue alert. So if we know that there's something happening that looks like it's a performance issue, and it's not necessarily generating red flags in your alerting things because they still think that they're kind of up, we can start telling you, hey, this looks like there's a trend showing up and it looks like performance is starting to tip over. Before it becomes a real problem, maybe we should look at this. And we just change our threshold values and create those different scenarios in which we can have these buckets of abstraction to make it really plausible and viable for you to make good reactive decisions. We're infrastructure, we can provide you better infrastructure and state awareness because we're actually not just looking at the actual individual object, we're looking at the transit path to the object. So while you might have an object in there or a container that's actually having issues, the issues on that container may not be the actual problem. Your actual problem may be upstream causing downstream effects. And since we can kind of look at all those transaction flows, we can give you a better view of that. And then we're multi-cloud and hybrid interaction aware. So if you've got multiple, and I guess we can check multi-cloud off on the number of times they say it. I'm just surprised we're not doing shots for this at this point. But being able to handle that transaction level and that kind of awareness is really fascinating because people's distributed stacks where they might have, something sitting in the Oracle Cloud, something sitting in GCP, something sitting in Azure, and this is my compendium of my actual application. Understanding how those things are routing and moving through your system is really difficult unless you have a synthetic client on the edge testing all those pieces from a transaction perspective. And it could very well be that your MFA provider has something messed up in their GSLB functionality, and their GSLB functionality is shipping them to someplace that's wildly far away, and it's slowing down application performance. So all your elements seem to be up and running just fine, but the end user experience is terrible because these other third-party pieces aren't doing what they're supposed to do. We can give you that kind of awareness and that kind of insight.
You actually need to be sitting there watching it, or
nope.
It can generate notifications for you. What types of automated capabilities does it have?
We can send SMS, we can send email, we can use PagerDuty, we can open up a ServiceNow ticket, we can do other API call sets, we can go through and call other API functions, Lambda functions.
Could you potentially, trigger a failover if you
Yep.
were, okay.
Not only can we trigger a failover, we could go through and we can modify our GSLB functions. We can go through and drop into the capabilities that your load balancers are actually using. You can spin up additional load balancers. Anything that we can script up from an API perspective and connect to somebody else's infrastructure, we can do as a triggered response. So Zebra Tester is our own scripting logic. And I'm not going to read through all this. You guys are welcome to read through all of it. I'm just going to talk very briefly through this because Daniel's going to do a really good demo for us. But essentially, Zebra Tester is a mechanism for us to go through, capture scripted information, and understand what's happening from a user perspective as you're kind of clicking through a web page. And by having this kind of proxy information in between, we can go through and actually create these really great, strong, powerful scripts. And those scripts can be used for load testing. So you can go through, do a local Zebra Tester instance, run it in your environment, grab that scripting information. You can run that standalone on your own environment, or put that into the Apica load test portal and actually be able to do these things at scale in an automated way that's simplistic, that has all the alerting capabilities and all the functional enrichments built into the system. So somebody asked about Selenium earlier, and this is very similar to Selenium. I've kind of seen these pieces. Yes, Selenium's a scripting capture engine. Zebra Tester does some of this. You can actually take some Selenium scripts and get them to us, so we convert them into an Apica format, and then we can load them into our scalable system. But at the end of the day, what we're trying to accomplish is giving you quick, easy ways to actually understand what your application performance looks like holistically.
Why Zebra, and what does Apica mean?
Oh, okay.
There's a story behind both those. Sure.
There is. And the story has been lost to time somewhere in the Swedish seas because nobody seems to remember why we picked Apica. Zebra Tester, we actually purchased somebody else and just never changed the name. The word pica means a small little mammal. So Stephen has bugged us 15 times saying, are you just a small little mammal running around doing this stuff? And then Zebra Tester, we don't have a great response for Zebra Tester, other than maybe it's tied to Marty from Madagascar. So yeah. So Zebra Tester monitoring, we take those same scripts that we did for load testing and we turn them into monitor functions, drop those things into place, and now we can start doing that interesting baselining and grabbing that information set that we think is actually of value. The next piece that we're going to talk about is DAC, and this is our desktop application check. So this is kind of the run anything, anywhere, and know your user's experience at a very, very deep and granular level. So kind of the quick facts on it. It runs on a Windows server runtime environment. It supports running multiple virtual machines to run any OS inside of the virtual environment. It supports third-party software plugins. It supports mobile emulators, and you can run it in any cloud or virtual environment. What it's doing is it's doing optical character recognition. So it's understanding how pixel detection works, how image detection works, looking at streaming interactions, and read and react to text. And it can also emulate keyboard, mouse, and tap. The cool part about this is that if you've got something out there where you have multifunction applications that are running in multiple environments simultaneously, and that's what your real users are using, we can emulate that. And we can emulate that from a Windows perspective, a Mac perspective, a Linux perspective, by dropping these things in their virtual machine environments and even handling the counteract quick back and forth between those different structures. Yes.
So a question here on application check. Can it react to video and audio?
What do you mean by react?
Well, when we're talking about detection and interact with or read and react to text, so could we include video and audio from a desktop application?
Yeah, so we actually, we'll actually detect stream rates, and we can go through and we can look for white space or blank space or drop sound. Like we can grab all those pieces.
Frame changes.
We can actually do that inside of the Zebra Tester as well in some of our other scripting sets. And we can actually take that Zebra Tester logic and we can actually apply it to desktop application checks. So we're actually able to stack functionality together to actually get these kind of cool compendium multi-factor function checks. And along those lines, you can also do things like emulate software environments for mobile and everything else on a desktop environment. So if you've got people that click back and forth, or do something like, I need multi-factor authentication on my cell phone so I can pop up and see SMS alerts, have these things pop up. I can actually do drag, drop, and pull them both across it. It's pretty awesome. We've actually got some interesting IoT use cases around this, where people are using this to emulate multiple IoT environments simultaneously, and being able to use that data interchangeably with how real users interact with that space.
Can I identify which pictures have a bus in them?
Which pictures have a?
A bus in them?
Not yet. I say yet. It's kind of hard to get past the Turing test for now. But as capabilities get better around those types of image identification functions, yeah, potentially in the future, we very well could do that. So next demo, we're going to cover advanced monitoring, and these are in no particular order. These are just the object areas we're going to capture. Daniel's going to kind of bounce back and forth between them because there's a lot of things that are going to happen in this demo.
All right, so for this demo, we're going to dive a little bit deeper into the monitoring platform and look at different check types that we have and different scripting tools and what we can actually monitor, the types of applications and things like that. Great, so what we're looking at here is I've logged in to my monitoring account in our SaaS platform. This is my dashboard, the different tests that I have set up. And this is how I group them together. This is completely up to you how you group this together. I have grouped them now just to kind of have a little bit of a theme. First one is user journey test. It means it's more than one step. I'm doing more than one thing in these tests. Then I have a couple of streaming checks. We're actually streaming videos from Amazon and looking at different bit rates and things like that. We have a couple of, actually only one API test here, which is a change API. We're using multiple services that are not really related, but I'll get into that, the details a little bit later. Then we have a couple of desktop application tests. One where we're actually opening up a VPN connection to be able to reach the application we're testing, and then how we can monitor real-time chat application and see if there's any delay between those. And then we have the most basic form of monitors, which is a single URL. Basically, it can be either a curl or it can be a real browser that just hits a start page or something like that. So let me dive into the first example here now, and to show you what we call 3 steps to root cause. So we have a script running here. It's a real browser, Chrome 87. It has a Selenium script attached to it that performs a few different steps. And this is the top level where we see the SLA for the last 24 hours. And we see the SLA percentage, but depending on what we set thresholds or if it's just failures. The next step, if I click into one of these, so this shows us the second step when we are trying to look at details for this script itself. It shows a graph over the last couple of days by default. You can even change this. We retain the data by default 12 or 13 months now if you want to go back and look at the performance. So you can change and take a look a couple of months back and see if you want to find trends. And this graph is really good at pointing out trends to see, okay, every Thursday at 10 o'clock, the response times went up by double. We can also change this to a table view, get a little bit more details around each check run here to see how many steps are in the script, to see if this actually, the response time for each and individual check. And then down here, we present the SLA per day, and you can change the time series here as well. So you can choose to look at a broader time span. And then we see what was the last check run response time, what's the median for the last 24 hours, what's our SLA right now, where is this running from? This is running from Ohio, and when is this going to run the next time? All right, so I want to show a couple of things here. One is a normal check run. So when you see this graph, this represents the response times for this script. If you see a red dot, that means it's a failure. So let me start by looking at a successful check run. So this ran today. And once we get into the next step, you'll see here at the top of the screen, it says exactly when this executed. So it was 8:25 this morning. And this ended at 8:26:13. We had 4 different steps in it and 259 URLs. And then we get some overview data here. What was the total browser render time? You can choose what you want to present here if you want to be DOM complete or something like that. How many DNS lookups we performed, how many connects, how many request round trips, how much data we passed back and forth. And then we get a list of what are all the domains we're hitting when we go to this website. And this is a really good tool for the first time we put a monitor up for a website, for example. We detect a lot of things here. I've seen several hundred domains in here. It could be, okay, we forgot to remove this third-party thing that we used for marketing 3 years ago. So it's a little bit of a troubleshooting as well to make sure you have a clean page. You see how much data you're downloading from each domain. And then you get a top 10 list of the slowest URLs and see what's actually taking time in this for these URLs. And this time it took 6.6 seconds to actually just wait for the server to send it back. So you get this for each URL. And then the next step, we come down to the waterfall graph, and it shows you how everything was loaded in the browser. And you can get these details for each and every URL as well. You see the protocol, and you see the color coding is explained here if you hover over the URL. And you see here in the waterfall as well how, when in time it happened, the DOM complete, for example.
We've got several customers that actually use this as performance optimization tool. So they go through and look at this and they're like, oh, we discovered that these people dropping pixels on our site for tracking purposes, it's slowing the site down. Great, we should fix that. Like, it becomes a really great troubleshooting tool in real time, but also from a functional testing perspective. It gives you the kind of visibility that you need to actually make a high performance application.
Mm-hmm. Then we're just going to quickly change this so we can show a pretty important part of this here, and I'll zoom in on this. So on the far right side, we have a little arrow here. You can expand per URL as well, every single URL in the script. And you can see a little bit more information about each URL call. For example, request headers and response headers, and how the previous, let me zoom in here. So this is per URL. You see the request headers, the response headers. So you can see if you got a cache hit or something like that. And you see, okay, so this took now 65 milliseconds to execute this first URL. Is that normal? I don't know. But then you can get a little bit of a hint to see the previous executions. It seems to be in that range. So that's just a quick validation to see, if you don't really know the application, how it's performing.
We've had several customers discover that there's things running on their site that they didn't know were running on their site.
Yeah.
So I mean, it's not uncommon for these types of things to happen. And it's not just the variable values that are there. They're actually able to go through and say, oh, the URL actually changed its origin source. It's the same URL, but I've just gone through and I've seen, oh, well, they've changed where they're actually pulling content from. So I mean, it's very effective.
Yeah, and you can also detect things like, oh, we have a blocking JavaScript here. Mm-hmm. So you see how things are loaded in, most of the things are loaded in parallel here, which is, normal browser behavior. But if sometimes you can see a big gap between, in the waterfall graph, suddenly there's nothing, and something starts loading over here. So it could be a JavaScript that's loading too early on the website and then blocking everything else from loading. So then we go down in this waterfall. So it's going to list all the different steps we had. The next step is a login. Next one is we're browsing images, and we have the same data for all of this. We tell you what type of resource it is, and I go down to the last page here. And so that's the data you get per check execution. If you run this every 5 minutes, you get this data per every 5 minutes for this specific script. The next step I want to show, since I call it 3 steps to root cause, is to show a failure. I'll do that for the same script here. So I'll pick this failure we had at 9:44. And it's right away, you have the same screen here. Right away, it's going to tell us in the result message that we had an error on step 2. And this URL, we had some a problem with. So let's dive a little bit deeper into that. So I'll go down here and we have then a box listing all the errors on the page. In this case, we got a request timeout from this NMetrics third-party application, which then reported. And once we get an error, you can choose to do this on every single check run if you want to. In this case, I set it so it'll take screenshots on failures. So you can go in and look, okay, what did the website look like during this execution? And you can step through and see, okay, what happened? We logged in, got to the web page, and it actually looks like everything was okay with the web page in this case. If it was a failed login, that would show exactly what the user would see it. In this case, it was a background metrics third party that failed. So the application itself didn't seem to be affected. So these screenshots are quite helpful in your troubleshootings.
And that showed up as a failure, even though it was the third party. I mean, I know it's part of the site.
No, it's
Is there a way just to, not mark that as a failure, maybe mark it as a warning?
yeah. No, that's a really good question, and we'll dive into the settings per check a little bit later. But when you set the check up and go to edit check, you can quickly just look here. You have a bunch of options for that. You can either do, in this case, I put a block in. So, sorry, here. So this Unsplash, I just block it. So don't load this because I know it's going to fail every time. It's a third party. It's normal. Someone probably needs to remove it. Or you can severity map. So you can say that if you get a 404 or a timeout on this URL, just treat it as information. Don't give me an error.
Oh, so specific URL, okay.
Yeah, or you can do, regex or
Not if the
something.
site gave you a 404, but if
Yeah,
404 embedded in there somewhere. Got it.
yeah. So that means we will still execute it. Will still show up as a 404, but it's not going to fail the check. It's not going to send an alert for you. So there's a couple of different ways to do that.
And you can report in metric sets that way as well. Like, these are interesting trends, but they don't necessarily need to be worrisome yet.
All right. So that was a real browser running. Now we're going to dive into a little bit more some other check types we have running here. Next up, we're going to take a look at a couple of scripts that we have done with Zebra Tester, the same tool we used for the first demo with load testing and monitoring. In this case, we're streaming videos from Amazon. So you're going to notice that these three steps to get to the lowest level and get all the metrics is going to look the same for most of these check types. It's just the type of data is going to look a little bit different. So we'll dive into this one as well. We see that this streaming is running every 10 minutes, it looks like. It's gone up and down quite a bit here as far as response time. But if we dig into one of these and take a look at the data we get back, for example, same thing here with Zebra Tester. We collect request headers and response headers for everything. So in this case, we are getting the manifest. In this case, we're feeding the manifest in dynamically, so we can change that if you want to. If you want to test a different stream or something like that, we are sending the bit rate we want to pick for this stream. And if you take a look at this, in the response headers, we see that this was uncached data coming back. It was a miss from CloudFront. And then the next step would be to actually read the stream itself, getting the video chunks until as long as we want to stream this. This case, we have the same thing here. You have the request headers, what we're sending here. And in this case, we say we got a hit from CloudFront here. Yep. So I'm showing in this case, it's one of the URL calls. We're setting the bit rate for this video stream. And we're looking at the response headers. And we see here that this was a miss from CloudFront. So this was not cached content coming back. We can get this for every single URL. And then the next step, we're reading the chunks of that video. And we can examine the same things here, the request headers itself, what we're sending to the server and what we're getting back. Like you see in this case, when we're actually streaming the video, it's being served from CloudFront.
Do you simulate the size of the video?
Yeah, we can decide how much of the video is streamed, and we can say which type of quality of the video we want to stream. So that's going to kind of determine the size of that video.
And we can set up multiple stream sets. So we can do multiple different patterns for the video itself. So if you want to see state changes, you want to see a break when a certain type of resolution change occurs or when a certain dropout occurs, you can actually spin up multiple different video stream checks simultaneously. So you can capture all those data sets simultaneously from a single client transaction. And a lot of solutions out there that try to do these tests, they'll do things like VBR testing, and they'll see a VBR dropout and the test will stop. And that's not a great way to see how customers actually use the application, because customers use the application that, oh, it's been stepped down, I'm going to keep watching it until I'm not quite as pixelated. So we give that kind of test methodology where we go through and we test all those stream levels simultaneously, so we can see when step downs occur or when video translation rates change or when full dropouts occur. But we'll repeat the test and keep testing it over and over again, so we don't just kill the test and let things die. And that's an important note. I used to work in video testing, and that was a very specific problem that we ran into with most of the test tools out there. They'd see something tip over, test is over, try again. We don't do that. We put things in a reuse queue, and you just keep doing continuous testing over and over and over again based upon the threshold windows. And if you're running multiple different frame rates simultaneously, you can grab lots of data that way and get really good information.
Yep, thank you, Jason. All right, so the next check type I wanted to take a look at, and that Jason talked a little bit about as well, are the desktop application checks. I have two different scripts running on a Windows desktop. The first one, we're going to open up a VPN connection, and then we're gonna browse on Amazon. So let me click into that one. First step. I see similar summary at the top here. You see this one is running from one of our own AWS instances in Idaho. We have the same graph with the response times. I'll click into the final step here. We get some of the information that's interesting in this case. So it will list it similarly to the other check types. We have a little bit more data to show on this check type. We show all the steps we're taking here. This summary is open a VPN connection, open Chrome, and then disconnect VPN. But between that, we do a little bit more things here. And you can even show the command arguments to each of these steps. So the first step, we open up a VPN connection. We get timings for everything here. Move that one. We'll pause, we'll double click an image. We'll wait for a specific pixel color before we move on. We'll left click at a specific area of the screen, wait for an image, and then we'll take a screenshot. And this is something in the recording tool for desktop applications. All this is predefined, so you just drop down, pick your commands, what you want to do with this application, and then we'll have a screenshot showing, okay, this is the first step. It's a Windows desktop. We have an open VPN client that we connected to. And everything that's going on this Windows machine will show up, of course. And next step, we're opening Chrome and browsing to a couple of different pages on Amazon.
And this is cool because we've got customers in the manufacturing area that actually use this type of technology to go through and track their CAD diagrams. And they have people connect in over VPN and see what the performance actually looks like. So they can say, oh, it takes a long time to load these CAD diagrams. People can't actually work in this kind of environment. We need to fix something. So it's that level of actual interaction, and especially user interaction, that's so valuable that we provide. And being able to show these screenshots in that kind of real time lets them see what these delineating factors are. So if they're actually getting error messages or timeouts, they know, oh, okay, the application's something wrong with that in the back end. But if it's just poor performance and your alert thresholds are set to the right values, you'll be able to see that and start tracking those pieces through. And we've actually had people go back through and say, oh, this particular area, a block of things that I'm trying to grab is having an issue because they've sharded their database in such a way that certain object types sit in certain areas. And by having these screenshots and having these different control functions in place, they can extract that very quickly with a visual tool without having to have somebody go through, log in, and try to replicate the problem set because the data is already there.
No question. Is this something most of your customers learn and apply and do themselves? Or do you have a pro serve team that helps them get to this point?
It's both. So we'll kick off helping customers from professional services perspective. And what we found is that most customers have their own way of doing operations and integration functions. And they've got their own run books and everything else. So we'll help them with that process. We'll help them with training. But a lot of our customers, once they get past like the 6-month mark, are pretty self-service because the tool becomes just part of their daily iterative process of what they're trying to load up and run with. So the UI workers, they tend to work in it quite often. And the developers are working with dev tools that they already know work in this space. And they just ship the scripts off and then the UI people bring it up, load it up, and it goes, or they have their own APIs that drop that into the CI/CD pipeline and it's automatically taken care of. And the reporting functions are very nice because you don't actually have to know how to use the system. You just get your reports, especially if you're like a C-level or a VP or a department head. You don't want to have to become an expert in the Apica UI. You just want the data that comes out of it. And we do that.
Not to throw a monkey wrench in your planned demo here, but can you show us something that, for example, a customer, like you kind of mentioned, right? A customer had no frickin' clue things were really bad. And your tool showed them, oh, no, you thought your problem was obviously here, here, or here, and it was way over there. You have something like that, to kind of show us?
Yeah.
'Cause, I mean, you're kind of showing us, yeah, you can drill in here and drill in here and drill in there. We get it. Not to speak for everyone, but something really unique about your product that you think sets you guys out from everybody else in the marketplace.
Yeah, I think we have a couple of scripts in here that is using more than just one kind of flow.
Sure.
That is a good question. And like Jason said, this is super popular now, especially with folks working from home, making sure your Citrix connects from home, VPN works always, and that the performance doesn't degrade when everybody logs in on Monday morning.
And similar to Jim's request, this bit with VPN doing the AutoCAD, being able to tell a little bit of a story of how you progress through stages. I mean, what you're showing us are like, we can run this test and drill down on it. We can run this test, but as a real user, how would I start with one test and say, okay, I figured out this much. How do I add on to it and move it forward?
Right.
So not just the story of a CAD place using VPN, but a story of what's the first thing they figured out, what's the next thing they figured out, how they built on this, and how they used your tool to actually do the building.
Yeah, a user story.
Yeah.
Of real true value.
We have something in here that's a little bit similar, but this is probably a little bit simplified in the demo. One use case was a customer that has a restaurant booking app, a native mobile app. So that's one part of the system. The other system is their backend system, which is actually receiving orders from the mobile app and actually making sure that that receives the order, the food order, and prints it out to the kitchen. So you want to press the whole end-to-end transaction. You want to make sure everything works. We created a script for that where we launch a native mobile application. In this case, I think it was on iOS. And we record all that traffic. You log into your account. You get your menu. You go ahead and submit an order for a hamburger. Next step in the same script, in the same user journey, we log into the backend system. We grab the ID of the order from the first part in the mobile app, and then we switch over to the backend system in the same script, use that ID to find that in the ordering system and making sure that the order actually came in and was printed out. There's one example where you do end-to-end, but it's two different applications in the same test. It's fairly common. It could be, you have customers that do customers, their end users, they use their website. It could be a banking application or something like that. They go in and they sign into their account, they perform an action, make sure that these other steps after that in your backend banking application happens. Did this transaction go through? Did it trigger this? So that it is common, and you know that's kind of the strength of this. That you can bake everything together in one script if you want to, or you can break it up and have separate scripts that does separate things as well.
Yeah, we actually have a really good MFA DAC story where people weren't able to actually use their physical authentication cards to go through and make sure they could do proper MFA and two-factor authentication into their live environments. So the initial use case problem was we need to be able to authenticate people and test this real user journey and show us what you can do. And nobody was expecting us to be able to come in and do physical card MFA. So we walked in and said, well, what's your scenario? They told us the scenario. We went through and said, well, do you guys want to test card taps to make sure those pieces actually work? Well, yeah. So we went through and basically did a discovery process to figure out the different elements that are wrong within the application environment. And there were some pieces that we found along the way where we see the application doesn't interact quite well, the performance doesn't look great. We suggest you tweak it in this way. But why don't we do these same tests with these physical card taps? And once we start doing the physical card taps, it's like, oh, so some of our application fluency problems might have to do with physical manual error problems, because the tipping point became, if you can do this card tap at a certain rate at a certain point in time, things tend to work better. And there's actually application fluencies in the real world space where those types of physical interactions make a difference. Like I don't click on something fast enough, or I don't move things around fast enough, the application times out because I'm not clicking through things in the proper order. You can build that into the test scenario once you know that thing occurs. But in the meantime, while people are going through this, you run this scenario the way that they're running this scenario. And then once you figure out, well, this is the pattern that they're using, awesome. Build that pattern in, see if this thing reoccurs, and either fix the application or have them change user behavior. And that's kind of the power we provide. We provide that kind of bridge layer between the cyberspace and the squishy meat space of human beings trying to interact with things.
Okay. No, those are the type of scenarios I was looking for.
Yeah.
And like the restaurant ordering scenario, the question I was going to throw on the end is, did you actually pass an acknowledgement back to the iOS app that said your order has been received?
Yep.
Yeah.
So you actually, you went from front end to back end, back to front end to cover the entire.
Yeah, so the last step would be order completed is what it says in an app.
Well, and the last step is that we actually deleted the order, so they didn't artificially make a sandwich. Yeah.
And once you get all that set up, if they add a special burger for the 4th of July,
Yep.
Is it all kind of all hooked into their CI/CD process?
Yep.
That actually comes down?
Modify the script, new object item, boom, good to go. And you don't even have to touch the system to do it. You just literally modify the script as it's there.
Either modify the script. In this case, we actually made it dynamic.
Yep.
So they had, and when you go into settings on these checks here, there's a field called additional options. You can send input data into the script. So for example, in this case, we sent a category ID in, like this type of food. So pick a random food item in this category. So you can send stuff in without having to download the script and redo it. We can make everything very dynamic and just send it in as variables here in the additional options.
I mean, in theory, you can go through and figure out who has better click and response time and better accuracy. The vegetarians, the vegans, the meat eaters, like you could get to that level of awareness if you really wanted to.
The people only ordering a sandwich, they can actually get to-go drinks.
Right.
Exactly.
I'm glad to hear that you deleted all those orders because you'd have a lot of PO'd.
We would have,
kitchen staff.
right, we'd have a lot of,
Right.
right. And but that's a huge part of completing the transaction is we have to clean up what we've done. And being able to do that in the real world environment and live transactions, I mean, that's a skill that a lot of the monitoring systems out there just can't do.
Right.
Which is why people don't use real user journeys for a lot of that.
Yeah.
Especially
Especially important. If
415 gets 300,000 pizzas is probably not a good thing.
Especially if you do a load test with 100,000 concurrent users,
Yeah,
it becomes
exactly.
kind of
Yeah,
important.
that's a good point. No, that's crucial.
Yeah, absolutely.
I can mention one other use case in that kind of which is similar, and I have a demo script here, which is not the full user story, but I'll talk about it. So this one is connecting to a website and uploading an actual file. It's uploading a image file. So we just see the steps here. So it hits a web page, it uploads a file. In this case, it's an image. It opens that file because you get a link to it on the web page, and then we go ahead and delete that file. The use case I was going to talk about is a customer that had an SSH FTP website where they had business partners upload documents. So we connect to SSH FTP, upload a file, and then we wait until a response file is returned in a different directory on that FTP server.
Okay.
We check a checksum in it and report back the results from that. So that's kind of end to end. We're even waiting, and we can set timeout. If it takes longer than 1 minute to get the checksum file back, it's an error because something is down.
And since we can do things like SSH and terminal emulation, you can do things like query your BGP infrastructure and potentially go through and make changes and have the rollback process be an undo, so you don't accidentally make a BGP change to a major financial dependency network on RFC 1918 address space and cause a 4-hour global outage of all ecom. Stuff like that. Like, that's the power of Apica.
Yeah, so now I want to dive into a couple of other check types we have here. One of them is we can natively run Postman Collections. And this is interesting because a lot of dev shops, they use Postman in their QA process. And a lot of times when you come to deploying an application in production, they already have test scripts for Postman. So you can just take that, upload that collection without changing it, and we'll run it as a monitor 24/7. The example I have here is a Postman collection. Let me go into the details of it so we can take a look. So in this case, it's maybe not a super realistic use case, but the first thing we're doing in this Postman collection is we're asking Google, the Google Maps API, give me coffee shops near me or near this address. The next call is, let me zoom in again. Sorry about that. Next step is, okay, from this address, we get the coordinates. Next step is, okay, give me coffee shops near these coordinates. And then we pick one of them, and then we post to send a message on Twitter as a recommendation. Hey, you should go check out this coffee shop. So this is running, this is showing that, these are not related at all, really, the Google APIs and Twitter in the same way. And then I think I do have my Twitter account up here, or if it went down, well, you can actually see that we are getting these messages. There we go. So now they're showing up here as a bunch of messages every 20 minutes, recommending different coffee shops.
So what's funny is that on April Fool's, my daughter signed up her boyfriend for a random fact about Nicolas Cage every 15 minutes that got sent via SMS. This is an awesome tool to do that for people in your company.
And what's kind of cool with Postman as well is you can, attach JavaScripts. You can have as many assertions as you want, and everything that you have in here will show here. Okay, we're testing that the status code is 200. We're getting the result we want from that JSON back from the API, and then we have 2 more calls, and we're making sure that the status code is 200 as well, and that we then get an ID back from the last call there as well. So this, you can have 100 different assertions in this if you want to test the response content, whatever you want to test, because we capture the full response content, headers, things like that. So whatever you want to look for and report on, you can add that as well. If you have variables in your script, they will all show up here. So for example, you want to show what value a variable had in your Postman collection during runtime, and you expose it in Postman, it shows up here.
Yeah, and this is, again, a really good example of how we're kind of bridging that gap between cyberspace and the real world. And you can use this as your imagination desires. So you think about things like connected car infrastructure, logistics, coordination, all those pieces. We can do all those things in an automated way for all of your testing and user interaction functions. And we can emulate what people are actually doing in the real world. Because somebody's sending a text message out that says, you should go to this coffee shop after doing a Google search. I did that 3 times last week if I'd try to figure out somebody close by where we can meet for coffee. So, I mean, this is real world stuff in an interesting way.
Yep. So the last kind of scripting style I wanted to show you is something we call scripted checks. And it's a check type that is based on code that you write. So whatever you write in Python, JavaScript, or Java as a Java jar, you can run as a monitor here. And we have a couple of examples here that we're running. We'll see what flavor we have for each of them. But we can take a look at this one. So this is a script that is connecting to a Docker host. It is querying that host for all the containers running in it and asking for average CPU, memory, utilization, and those things. So we can click into it and so you can see what it looks like. In this case, we see up here, this is the flavored run JavaScript. It could have been Python or real Java as well, which opens up a lot of power here. So whatever you can write in code, you can run as a monitor basically. So let us go in. We do see that in this case, and in these styles of scripting, you choose what the return value is. So we see here that in the graph that we had a very low number, 2, 3, and then it jumps up here, 100. What does it mean? It's not a response time like a normal web browser checks or things like that. In this case, I know that we're returning the average CPU utilization for that Docker host. So if you'll go into one of these specific check runs, and this ran yesterday, right, at 7:42. And the kind of beauty of these is since you can write your own code and you can check whatever you want. If you want to restart a EC2 host, or you want to log into your firewall and fail over something, or open and close ports, or perform a disaster recovery by redirecting traffic. In this case, we're getting the Docker containers information, CPU memory percentage, CPU percentage, memory usage in megabytes, and the memory percentage. And we loop through all the containers we have here, and then we return the average of that. So it's up to you what you return. So it's very flexible. And whatever, the only thing you need to adhere to here is that we expect the response to come back in JSON format. Then we can present it for you. We can alert on the values you return as well. That was one example. We have a couple of other ones as well in this scripted check type.
Right, and it's agentless. That's the other thing. Like you can actually pull container information, CPU, memory, disk, network, whatever you want from an agentless fashion as a polling mechanism. And you can do those things specifically for certain check types. You can group things together in interesting ways from a client-side perspective, understand what your user journeys look like, and then grab those individual components. So like if I need to grab what my load balancer CPU utilization is, or my load balancer capacity is, whatever, I can grab all that and understand all that logic flow right there. By setting things up in this way and keeping these monitors in place, I should actually know ahead of time why my client is having issues in certain areas and not have to figure out how to triangulate a distributed application set across a global network. Because those access points are there, it affected these customers in this way, DNS went in this direction, boom, it's this problem.
Yeah, well, I was just about ready to ask
if
it actually had the capability of displaying multiple things on the same graph, so you could actually attempt to see some of the correlation, because most of what you've shown so far is just a single trace graph.
Mm-hmm. Yeah, so this style, in this case, it's JavaScript, so you can write as much code as you want to compare and pull different things in. What you return back as your value is up to you. In this case, is just another example. We're connecting to a Windows host and getting a service state of 2 different services on Windows. We're saying that SSHD is running, wsearch is stopped. And then you can alert on that, oh, this service on this host stopped. Only your imagination is kind of the limit here when it comes to these style of checks. If you're comfortable writing Python or JavaScript or Java, it's a powerful tool.